Hi, and welcome back, everyone. We're going to look at law of sines now problems. So this is video 2 in this chapter, and this is Foundations of Mathematics 20, Acute Triangle Trigonometry. And yeah, so this is really still the first topic, but that video is getting long. So we're going to look at the problems now. So one thing that we'll have to talk about is compass directions, and this is just simply pertaining to the textbook that we are using for this class. So this is not something that's tied directly to sine law. So these styles of questions come up in this textbook, so that is something we should talk about. All right, so when they give you something like this, north 30 degrees to west, north 30 degrees west. So the first thing we should remind ourselves is of the compass directions. Okay, so we got north, south, east, west. Use whichever kind of funny rhyme you want. Never eat shredded wheat, whatever you want to remember it with, okay? Yeah, so now the thing you should know here is that it's actually easier to read these things backwards. So we're going to start here and read it backwards, okay? At least it is for me. So the way I'm going to interpret this is I'm going west 30 degrees from the north line, okay? So all of these directions, you're going to be coming off the north-south line. You are never, ever going to be coming off the east-west line, okay? But we could write it that way, but just you won't be doing it, okay? So I'm going to go towards the west 30 degrees. Now, we do not need a protractor or anything, so just kind of draw something in that west, going to the west side. I could say, yeah. Anyway, and then I'm just going to say that's 30 degrees there. Okay, so we don't need to get out a protractor. So I'm going 30 degrees west from that north line. All right. Here. Okay. So again, start here, read backwards. So east, never eat soggy wieners. I'm going to go 70 degrees east. So I'm going in the east direction, 70 degrees from the south line. So that's a bit bigger, I'd say. So like that. I'm going in an eastern direction, 70 degrees from that south line. Let's try this one here, a little bit smaller. East, west, starting with the east, read backwards. So I'm going to go in an eastern direction, 62 degrees from the north line. Okay, last one. Again, east-west. 12, we're going to go west 12 degrees from the southern line. So west 12 degrees from the southern line. And really, that should be a sliver, should be less than that. But that's okay, we don't have to be actually accurate. Just make sure you put your number in there, okay? We're representing the situation. We're not truly drawing the situation. So remember that. We're just going to represent the situation. All right, so I just have two examples for you, okay? Now, there are kind of two types of problems. There's a problem where they draw it out for you so you can kind of already see the situation in the triangle. We don't need to practice those because truly that is like our first video. It's just there's a reason for the numbers in the triangle now, where in our first video there wasn't a reason. I just gave those numbers, okay? But in one type of problem they'll explain, you know, Tom and Joe are 14 feet apart, and that's why there's a 14 between the T and J, okay? The second type of problem is when you have to draw it yourself. That takes more of the work. So those are the two that I'm going to do. So in both these examples, you're going to have to draw your own triangle. So it's good to read a question twice. Once just to understand, like, get the situation, like what is the story about? And then the second time to start picking numbers out. Okay, so the captain of a small boat, C, is delivering supplies to two lighthouses that are 12 kilometers away from each other. It says his, so I guess it's the dude who's driving this. His compass indicates that lighthouse A is located 9 kilometers away from its present location at north 30 degrees west, and lighthouse B is located at north 50 degrees east. What is the angle between lighthouse B's line of sight to A and boat C? Okay, well, we'll look at that in a second. I tried simplifying the question, but I don't know if that actually looks a little bit tough too. So there's a guy in a boat, right? And you can see the two lighthouses. So you can imagine a triangle there, a boat and two lighthouses. There's 3 points, right? So now I'm going to start picking out things. The two lighthouses are 12 kilometers away. I know that. But I also know that they're everything's kind of relational to the boat, right? It says his compass indicates that lighthouse A is located 9 kilometers from his present location. So I have to know where the boat is first, and then it gives me the directions here. And then lighthouse B is located at those directions. So everything is related to this ship's location. So I'm going to put my ship right there. Okay, and then what I'm going to do is, you don't have to do this, but I like just to draw my directional lines again. And I know that the first one is north 30 degrees west. So I'm going to go west 30 degrees from the north line. Okay, and that's A. So this is 30 degrees west from that north line. Okay, and we know that that is 9 kilometers. So this is C, by the way. So I've done this one. Then it tells you that lighthouse B is located north 50 degrees east. So I'm going to go east 50 degrees from the north line. Okay, so that's B. And then obviously I can connect those. So I've got that. What else do I have? Well, it tells me that they're 12 kilometers away, the lighthouses. Okay, sometimes when you draw these, they can get more detailed than this one, and they can be kind of messy. So sometimes I draw 2 of them. I'll draw one kind of rough copy right here, then I'll draw a nicer version. So now the one I've just drawn, my rough version wasn't really that rough. You'll see sometimes they can get rougher than that. And then to find C, that's 80. This is the only reason I redrew this one, is that that's 80. Okay, so now they're wondering, what is the angle between lighthouse B's line of sight? So a line of sight is when you go from B, the line of sight is if we look at A in this case. So the line of sight to A and C, okay? So really we're looking for angle B. Okay, we're gonna look for angle B. Now if you wanted to use the menu, I guess I could call it, the list, like we did last time, go for it. C is 80, side C is 12, B is 9, okay, and then we're looking for angle B. So in the previous video, we solved every single time. Solve is when you find everything. You don't always have to solve. They might just ask you for one piece of it, okay? Remember that there's 3 things you'll have to find if you want to solve it. So you might just be asked for 1 out of 3, or sometimes you have to do 2 out of 3 because they only really care about the 1, but you have to do a pre-step first. Anyway, so let's look for angle B. So I'll start with my C's. 12 over sine 80. Again, when you have a row, you're good to go when it comes to sine law. And then this is sine B, and now I'm going to cross multiply. I always bring the unknown to the left side because in math we like having our variable on the left side. It's a convention thing, which means it's like the accepted way, preferred way. Okay, and then now I want to divide by 12 because I don't want 12 times sine B. So again, now you have sine B equals that. I don't want sine B, I want angle B. So that is when we tell the calculator, hey, I'm going to give you a value. Could you please go backwards and find what angle belongs to this value? So inverse sine, and then now I input the right side of my fraction. Again, the biggest thing that people trip up with in this chapter is their keystrokes on their calculator. Once again, make sure you are in degrees. Okay, so for my calculator, I go second function sine first, and then I like to put a bracket for my numerator. And I'm just pausing here to calculate it in real time as well. I feel it slows me down in the video so I don't fly as much, which is good. I'll go to 1 decimal place, 47.6, and we are finding an angle, right? Yes, we are, degrees. Okay, so that would be the angle between there. All right, so the big thing to take from this is drawing a triangle yourself, okay? So this information here, that's the new stuff. This stuff over here, that is the stuff you did last video, so that should be kind of old and hopefully easier now. All right, last example, and only my second example. Tracking stations A and B are 38 kilometers from one another in an east-west direction. From A, the direction of the ship C, the direction of a ship C is that, north 22 degrees east. From B, the same ship is north 55 degrees west. How far is ship C from station A? Express your answer to one decimal place. All right, so again, we have this time 2 tracking stations and then there's 1 ship, okay? Which is kind of similar to the last one, right? They had 2 lighthouses. Anyway, it tells us that this east-west direction, okay, these tracking stations. So what I get to do right away is I'm going to draw the east-west line, okay, that flat line, and then I'll call this one A and then this one B. So that's my tracking stations. I drew them very far apart. I don't know why. Anyway, from A, the direction of ship C is north 22 degrees east. Okay, so there's my north, south, and there's kind of my east, west. I'm going to go, I'm going to go eastern 22 degrees from the north line. So 22 degrees off there. Okay, now when you draw this, again, we're just representing it. We're not drawing it perfectly. Some of your angles may not really match up to what you know the number is. Like sometimes it should be a sliver and you draw something bigger, or you end up drawing something bigger and it should have been smaller. Again, as long as your number makes sense. And it's good if you can kind of catch maybe drew it improperly. Okay, so for this one, we're going to go west 55 degrees, and I don't really have a choice. I need to make it match up, right? But that's actually likely pretty close. That's 55 degrees. Okay, we did that, and we did that. Oh, we forgot that they're 38 kilometers apart. Okay, so now, another piece that's nice in this question is north-south lines and east-west lines. What kind of angle do they make when they meet? And if you're thinking, oh, those are perpendicular lines, you are right. So they make a right angle. So if I know that, and that's going to be a right angle here too. So if I know that part of that angle is 22, the part that's inside the triangle will be 90 minus 22. So 90 minus 20 is 70, and subtract 2 more, 68. Now 55 degrees, sorry, I was just playing with my microphone there. 90 minus 50 is what? 40, subtract 5, 35. So there we go. And then what are we looking for here? How far is ship C? Oh, this is C, by the way, from A. So we're really looking for this distance here, which we would call it, by the way, according to this triangle, we'd call that B. Okay? So again, if you like this, oops. So A is 68, B is 35, C we don't know. C is 38. And do I have anything else? I do not, right? And we're going to be looking for B. B is the one we really care about in this one, okay? So I need a completed row before I can use sine law. I don't have it initially, so I'll have to kind of work with this here. I need to find angle C. So this is what I was talking about, where angle C is not really anything. It's not part of the answer, but it's required in order to find the answer. So I can go 180 minus the known angles, 68 minus 35. I don't know why I'm not just doing it in my head, because I can do that. But for some reason, I am second guessing myself on the video. So 77 degrees. Okay, now I have my full row. Yep, that was a voice crack. Now I have the full row. I can find this B. So I will go 38 over sine 77. If you wanted to use my shortcut in this one, you could have too, but again, I'm going to shy away from it. It's easier when I'm in class to show something like that, I think. Sine 35, and now cross multiply. And we do the same thing we've been doing. I'm kind of quiet because what is there to say at this point? You know this aspect of it. It's all about the picture, this video, really. Okay, so let's calculate this. Alrighty. 22.4 if I go to one decimal place. And that is kilometers, everyone. And yes, we should have a little phrase or sentence here, but I'm going to stop it because we're at 15 minutes. Last one was in the 20s, so this is getting to be kind of long, maybe. All right, so there we go. That's sine law. So sometimes you're just given a triangle without a story. Sometimes you're given a triangle with a story, and sometimes you have to create that triangle yourself. All right, so if you are needing some more assistance, make sure you talk to your teacher. Again, if I'm your teacher, talk to me. Bye, everybody.